Here's a thing language models are good at. You ask what's our refund window, and you get a confident 30 days in clean prose. It sounds like someone who works here. It isn't. The model has never read your policy. Fluency is not a lookup. That gap is why RAG exists, and it is the whole subject of this lecture. By the end of this, you'll see the loop that fetches evidence before the model writes. Dumping the whole library into the prompt does not work, because the window is finite. And a lot of what looks like the model lying is a missed retrieve one step earlier. Fix the index before you blame the prose. That is the habit this lecture is trying to install. The model you are talking to was trained on a snapshot. After that, the weights are frozen. Your refund policy is not in there, and next week's policy will not be in there either. You can ask nicely. You can prompt it to be careful. None of that opens a file. The knowledge cutoff is not a vibe. It is the training date, and your docs sit on the other side of it. The obvious fix is to paste everything into the prompt. That dies on the window. A long context still has a budget, and a company wiki does not fit. Even when it does, the useful sentence gets lost in the pile. You do not want the model to read the library. You want it to read the page that answers this question, and only that page. Fine-tuning feels like the grown-up answer. It isn't, not for facts that move. Fine-tuning changes the weights. It is a poor database for facts that keep changing, slow, expensive, and stale, the moment legal changes the number. Retrieval leaves the fact in a document you can replace tonight. That is the cheaper way to be current, and it is the way you can cite. So the move is almost forced. Do not ask the model to remember your docs. Fetch the few passages that might answer this question, put them in the prompt, then generate. Retrieve, then generate. That is retrieval-augmented generation. The name is just the pipeline, set in order. You index first and you write last. Before any question arrives, you break the corpus into chunks. A chunk is the unit you can retrieve later. Embed a whole chapter as one point, and the useful sentence gets averaged away. Embed every line, and you retrieve fragments with no context. Chunking is the unglamorous decision that makes the rest of this work, or fail. You do this during ingestion, before query time. When the source changes, you ingest again. Each chunk gets an embedding, an address in the same kind of space the last lecture built. You store the vector next to the original text. The index is not the documents. The index is a map from meaning to those passages, so a later question can find them without reading the whole shelf. The query and documents must land in a compatible embedding space. At question time, you embed the query into a compatible embedding space. Wrong space and the geometry is junk. The question is now a point. Search is nearest neighbor, not a keyword ritual, though keywords still help and we will come back to that. Right now the job is, which stored points sit nearest this one? That is retrieve. It is not generate. What comes back is not the answer. It is the K nearest chunks, usually 5 or 10, sometimes 20 if you plan to re-rank. Approximate search is fine at this stage. You are buying candidates. Miss the gold chunk here, and no later step can cite it, because it never entered the prompt. Top K is a short list. Treat it like one. Those chunks get stuffed into the prompt, usually under a system instruction that says answer from this context, and if it isn't there, say you don't know. The question sits with the evidence. The model has not become more truthful. It has been handed a short reading list for this term. That is all stuffing is. A reading list this once. Then the generator writes. Next token, then the next, conditioned on the question and on whatever you stuff. The embedding did not write the sentence. The language model did. Retrieval only decided which passages it received. That split is the whole architecture, and it is why a bad retrieve looks like a bad answer. The prose can be perfect. The evidence can still be missing. A citation is a pointer back to a chunk, not a proof that the sentence is true. The model can quote the right document and still twist the number. It can also invent a citation that looks like yours. Treat the bracket as a trail to go and read, not as a green tick. If you do not open it, you have not checked. So the loop is 4 moves. Index the corpus ahead of time. Embed the question. Retrieve the nearest chunks. Generate with those in the window. That is RAG. Everything after this is why that loop fails in production, and which knob you actually turn. The rest of the lecture is the failure modes, not a new architecture. Chunk too big, and the useful semantic signal gets diluted. A 2,000-word page becomes 1 point, and the sentence about refunds is washed out by shipping and hours and a footer. Nearest neighbor returns a document that is about the company, which is not the same as answering the question. Size is a relevance decision, not a storage one. If the useful line is 1 in 40, the vector will not remember it. Chunk too small and you retrieve a fragment. 14 days with no subject. The model will happily glue a subject onto it. A chunk has to be a thought, not a leftover clause. If a person could not answer from that span alone, neither can the retrieve. Fragments invite the generator to invent the missing noun. Overlap is the boring fix for a sharp knife. You let consecutive chunks share a few sentences, so the idea that sat on the boundary lives in both. You pay a little extra storage. You stop losing the one line the question actually needed. Most production chunkers do this and never mention it. It is unglamorous, and it is usually right. Not every nearest neighbor is eligible. Filter on tenant, on date, on source before you rank, or you will retrieve a true paragraph from the wrong customer. Metadata is not a vibe. It is a hard gate. Semantic search without a gate will cheerfully fetch someone else's policy because the language matched. Near is not allowed. Keywords still help. A SKU, a ticket id, a function name, those are exact token, and cosine can miss them. Hybrid search runs a lexical match alongside the vector match, then fuses the two lists. Meaning catches the paraphrase. The keyword catches the identifier. In a lot of real corpora you want both, because neither list is complete. First stage retrieval is cheap and a little messy. You pull 20 candidates, then a reranker, a cross-encoder that reads the question and the chunk together, puts them in a better order. The gold chunk that sat at 12 can rise to 1. You pay a second model, so the prompt is not stuffed with near misses. Cheap retrieve, expensive second look. That is the usual split. Even the right chunk can fail if you bury it. Long prompts often show position bias. Evidence buried in the middle can receive less attention. Stuff 5 chunks in a random order, and the useful one goes quiet. Put the best evidence at the edges, or keep the prompt short enough that there is no middle to get lost in. Retrieval can succeed and still lose inside the window. If retrieval misses, the model cannot cite what it never received. It will still write. That is the training objective. So a lot of what looks like hallucination is a nearest neighbor miss one step earlier, dressed in fluent prose. Fix the index, the chunk, the query, before you reach for a new generator. The writer was doing what writers do. The index is only as current as the last ingest. Legal posted 14 days this morning, and your vectors still say 30. Retrieval did its job. It retrieved the truth as of last week. Stale is not a model failure. It is a pipeline that does not notice the file changed. Re-embed when the source moves, or you will cite yesterday. The metric that matters first is recall at K. Did the right chunk even appear in the K you stuffed? If it didn't, generation never had a chance. You can score answers all day and still miss that the evidence never arrived. Check retrieve before you check prose. A beautiful wrong answer is still a retrieve miss you failed to see. The second check is faithfulness. Given these passages, did the answer stay inside them? 14 days in the chunk and 30 days in the sentence is not a retrieve miss. That is the generator leaving the evidence. A high cosine got you the right page. It did not chain the model to the number. Grounding is a separate test from retrieve. Put it together, and RAG is a fetch with a writer on the end. Index query retrieve stuff generate. It fails when the chunk is the wrong size, or the gold passage never ranks. It fails when the prompt buries what you found, or the file is old. The knobs live on those arrows, not inside the model card. Turn the pipeline. Do not swap the generator first. RAG is not memory. It does not create persistent memory by itself. The application decides what survives into the next turn. Nearest neighbor is geometry, not a person who read the handbook. You still need a generator that can use what it was handed. Retrieval buys evidence. It does not buy a mind. Keep those jobs separate, and the system stays honest. One last thing, because we still skip the hard part inside the generator. You stuff the evidence. The model still has to decide which of those tokens matter when it writes the next word. That mechanism is called attention. It is how a transformer actually reads the prompt you just built. Next time we look at that.